Welcome to our session on confidential containers on AKS. I'm 𝗦𝗲𝗀𝗀𝗃. I'm a product manager with the Azure Confidential Computing team. And joining me today is 𝗦𝗲𝗀𝗀𝗃𝗀𝗃, Senior Product Manager from AKS, and Bryce Fisher, Senior Engineering Manager, also from Azure Confidential Computing team. Today, we want to cover integrity and confidentiality protected pod environments with remote verification. If you're not familiar with what confidential computing is, it is the latest in integration and security of your workload. So existing encryption helps you protect data when it's at rest or when it's in storage and when it's in transit. What confidential computing aims to do is protect that last leg of data of when it's in use. And protecting data in use protects you from insider threats, hackers, and third parties. Microsoft is a founding member of the Confidential Computing Consortium, and that sets the definition of what confidential computing is, which is what we also follow for our confidential containers product. So that begs the question, what makes a container confidential? In this diagram here, you can see that I've created some threat matrix that we want to isolate our container from. So we want to have container level sandboxing and isolation, and we want to operate with a zero trust threat model, both from our security and operator access. Apart from being able to isolate our container, we also want our customers to be absolutely sure of what's running there. So we want to provide both transparency and auditability of all the components operating in that trusted computing base. And lastly, we want to have code integrity and protection from the shared OS, which means that there is no malicious code that can be injected or altered in the container that's running. Of course, since it's a container, we also want to maintain the best of what running container workloads offer, which is both cost optimization and not having the need to modify your standard containers. I'm now going to hand it off to Michael, who's going to go into a little bit more details about what forms the foundation of confidential containers and some of our product details.
Thank you, 𝗦𝗲𝗀𝗀𝗃𝗀𝗃. So the foundation of confidential containers on AKS is all about the community. Whether it's Azure, Cloud Native Computing, or the Open Infra Conference itself, leveraging Azure Kubernetes Service, confidential containers, and Kata containers, holistically is what brings the ability for us to bring confidential containers on AKS to our community. Looking at the product features in detail, starting out, obviously with confidential containers, we bring in the ability to isolate the pods from the Kubernetes control plane. This allows you at the top level to protect from cluster admins, Kubernetes admins, API level attacks that might exist. But down at the compute level as well, through the nested virtualization that we're doing, you also are protecting trusted versus untrusted applications as well down at the node level. This also brings in memory of each pods now that they're encrypted with a unique key from the hardware layer. As 𝗦𝗲𝗀𝗀𝗃𝗀𝗃 alluded to before, you can run any Linux container unmodified, and it's heterogeneous node pools running GP, SGX, GPU in a single cluster. And the implementation is fully open sourced for auditing. A single VM node can create multiple confidential container environments, and you pay for just the base VM and pack many pods and containers into the environment. So think bin packing your applications. And how do we bring all this home? So obviously providing full raw attestation reports, access to the applications, the ability to configure policies and key release to protect from insider threats is the complete capabilities that we bring to provide confidentiality. So looking at the trust boundaries, what we're essentially talking about is building capabilities that lock the environment out and build capabilities outside of the trust environment. So if you look on the left, you see the functional trust software components. You have the Kubernetes shared host OS, the kubelet at the control plane level, Hyper-V itself, the rootkits, the bootkits in the host OS, the host operator at the operator trust at the admin level, AKS operator admin, AKS cluster admin, tenant admins are all outside of the trust boundary of that application. And lastly, as you kind of bring this home from a solution perspective, on the left is our standard implementation without Kata and without Cocoa in the implementation. So by default, as everybody's aware, when you deploy an application, it's running on the shared kernel, which is there on the left. And you can isolate them by running maybe on a dedicated node or node 3, node 4, and you can segment your applications that way, but they're essentially all running on the shared kernel. Now, when we go to the right, with the Kata implementation that we have, is that starts out with the child VM, Kata VM, which basically now gives you the ability to run that application on its own kernel. So if there is a compromise on there, that compromise is only compromising itself. But think of that as just providing that compute level isolation. As you look at the CoCo implementation on that, that is providing that encryption boundary around that capability, which now locks out the admin and the API server from the top level as well, providing control plane and data plane security for your application set. Now I'll turn it over to Bryce to actually go through a demo of the solution.
Thanks, Michael. Yeah, today I'm going to go through a demo we have for Azure Confidential Computing on AKS. And we have very exciting where we're going to do end-to-end encrypted messages on Kafka, starting with our Kafka producer running outside of a confidential environment, all the way through to the Kafka consumer running inside of our confidential environment. But of course, we want to do it all with our confidential twist that we have going on today. So we've got everything running in a couple different environments. The two boxes on the left in blue, those are going to be running outside of a confidential environment. So regular Kubernetes pods, just like you'd have anywhere else, producer in the service. So what we're going to add those, we're going to be doing end-to-end encryption of these messages, and we're going to make it so that only the pods running inside of a confidential environment are able to decrypt those messages. So we're going to have a public key over there in the Kafka producer. It's going to encrypt it before it sends them, and then those encrypted messages are going to flow through to the Kafka consumer on the right side in the red box, which will be running in our confidential environment. In order to obtain those keys and make sure that the entire environment is still safe and trusted, the Kafka consumer is going to use one of our containers that we've provided called ASP, the Azure Attestation and Secret Provisioning Container. That's going to act as a sidecar to interface out with MAA, the Microsoft Attestation service, and our managed HSM key vault down there to fetch those keys. Those three things acting in orchestration are going to validate your environment and make sure it's safe. Let's dive into the demo. All right, starting out the demo, what I have here on the left side is the pod YAML that I'm going to be using for the consumer we just talked about in the last slide. On the right side is a terminal I'm going to be using to help generate the security policies to make it safe and also interact with the AKS cluster. So the first thing I'm going to want to do is generate the security policy that we're going to be using for the confidential consumer over there. So we're going to be doing that with an Azure CLI extension called conf-com. It has a subcommand called Kata policy gen, and that's going to consume directly your pod YAML that you've developed for your pod. And as I discussed, as you can see on the left, the pod YAML over here, it has the ASP container that we have at the top, and down lower, we have our consumer container over there. As this is generating, all of the measurements, this tool is going to download your both containers. It's going to measure all of the layers that make up those containers. It's going to grab all of the configurations from the Docker files that made those containers, and it's going to pull all of the extra configuration that's found in your pod YAML. It's going to compile all of that together in what we call our security policy, and then it's going to add that security policy back into this pod YAML directly for you, so that it can be transmitted to AKS alongside this pod YAML. Now that the policy is finished generating, you can see that it's been automatically added into the annotations on the pod YAML on the left side. Other configuration items to note is we need the runtime class, Kata CC, in the pod YAML to tell Kubernetes that it needs to be deployed as a confidential pod. And just above it, we also have configured a managed identity in Azure so that it can access the MHSM and export the key at runtime. Next thing we're going to do is we're going to ask MHSM to generate the key pair that we need to encrypt and decrypt the messages. First, we're going to get the hash of the security policy. We're going to set that hash into an environment variable called over here for the workload measurement, along with the other necessary configurations for which MAA we're going to use and what managed identity we're going to use. And then we're going to run this script, and this script is going to set up that key and ask MHSM to generate the key pair and also export out the public key. What it's also going to do is it's going to set a key release policy in MHSM, which is the underpinning of trusting the security policy. Once that key release policy is set, it is going to check and make sure that the pod is running in a confidential environment, B, that the confidential environment is not set to debug mode, and C, that the security policy hash matches the security policy hash that we just generated a moment ago from the security policy in our pod YAML. We've successfully created those keys, and now we're going to take the exported public key, and I'm going to copy and paste that into the producer pod YAML right here. This gives the producer pod YAML the ability to encrypt the messages with no other component other than eventually the consumer to be able to decrypt them at runtime. One thing I want to do before we deploy the confidential container is I want to demonstrate that it is not possible to decrypt any of these messages outside of the confidential environment. So we talked about adding the runtime class and that being necessary. I'm going to comment that out. I'm going to comment out the ask sidecar container because it's not necessary if we're not releasing keys. And I'm going to comment out the security policy. This now turns my consumer pod into just a regular vanilla Kubernetes pod, and I'm going to deploy that to AKS. I'm going to quickly grab my public key here so that I can demonstrate all of this in my web browser. So I deployed that, and as you can see in just one moment, or I've pulled up my web browser, I've deployed my pod, and as you can see here, the message contents are all encrypted, and we cannot see them. And that is because I'm not able to release those keys from MHSM without those 3 facts that we discussed just a second ago being true. Now what I'm going to do is I'm going to delete that pod. I'm going to uncomment out everything I just said that I was going to uncomment, turning it back into a confidential pod. And I'm going to redeploy this to Kubernetes. And now, as you can see, when I redeployed up the confidential version of the container, my messages are being decrypted and then displayed on this website. And so what happened here is now that's running as a confidential pod, the ASP container on behalf of your workload container was able to fetch an attestation report from the hardware, turn that into an attestation token via MAA, and then finally retrieve the private key from MHSM, providing all of my evidence and my managed identity and exporting that back into the confidential environment. Then once inside of the confidential environment, I was able to read those encrypted messages we saw just a moment ago, decrypt them, and display them up on the web page here. On behalf of Azure Confidential Computing and Azure Kubernetes Service, I thank you for joining us today for our demo of confidential containers on AKS. If you'd like to learn more, please follow the link below on your screen, and we look forward to seeing you in the cloud soon.